15 by 8. This is 8 3s, 8 4s. Right? 18.
TH plus TO by 2.
TH plus TO.
TH plus
TO.
by 2. Huh? Okay. Now, after mixing, what will be the RMS of oxygen now? Under root 3RTC divided by molecular weight. No? Hello?
Yes, sir.
So it will be under root 3R by 2mW into T1 or TH plus TO. So it will be under 3RTH is 4000 plus 3RTO is 32,000 divided by 2 into 32 into 10 power minus 2. How much will you get? 36. 36 by 64.
6,000.
6 by 4. 6 by 4 means 6 by 8. 6 by 8. 3 by 4. 7.5. 0.75. Options should contain 0.75 something. So it is 750. Understood? Third question you have. No. One second. Let me just see. A ring-shaped tube contains two ideal gases with equal masses and atomic mass number M1 32 and M2 28. The gases are separated by one fixed partition P and another movable conducting partition S. Acha, which can move freely without friction inside the ring. The angle alpha as shown in the figure in equilibrium is. Okay. I cannot move individually. Okay. So this which is there is P, isn't it? Which it is there is S. So S is movable, right? And this is alpha. So this gas is M2 and this side the gas is M1. Isn't it?
Yes,
see,
sir.
it is in equilibrium means
P of 1.
say pressure exerted by 1 should be equal to pressure exerted by 2.
Yes, sir.
Yes, sir.
So, and see, it is not heated and everything, right?
Yes, sir.
So
Yes, sir.
temperature should also be equal. Yes.
Yes, sir.
So see, PV is equal to nRT. So from this, V is directly proportional to N, isn't it? Number of moles.
Inversely.
V amma, volume. Correct?
Yes, sir.
Now, V1
By
divided by N1 should be equal to V2 divided by N2. So, okay. Volume.
V1 will be equal to 32 by 28 V2.
Huh?
V1 will be equal to 32 by 28 V2, which is 7 by 8 V2.
No, he is asking the angle, no. I'm trying to get the angle. Volume. Okay, I'll take it as area into length. Can I?
Yes, sir.
Yes, sir.
So length, can I say for V1 it is 2 pi minus alpha, and for V2 it is alpha. Areas are same, gets cancelled out, right? So can I say this is 2 pi minus alpha divided by N1 is equal to alpha divided by N2?
Yes, sir.
He's asking alpha, no?
Yes,
So
sir.
2 pi minus alpha divided by alpha is N1 divided by N2, correct?
Yes, sir.
Okay, they say equal masses, right? So this, can I say, will be equal to M2 divided by M1? M1 is equal to M2, no? Equal masses. So number of moles is mass by molecular weight, no? So mass 1 divided by molecular weight 1 divided by mass 2 divided by molecular weight 2, no? Masses are same.
Yes, sir.
They get cancelled out. So it will become M2 divided by M1, isn't it?
Yes, sir.
Yes, sir.
Which is 28 divided by 32.
32.
7 by 8.
Yes, sir.
So 2 pi by alpha minus 1 is equal to 7 by 8. I don't want you to do like Nikita. 16 pi minus 8 alpha is equal to 7 alpha, like that. 2 pi by alpha is
15 by
7
8.
by 8
15
plus
by 8.
1. 15 by 8, isn't it? So alpha is 16 pi divided by 15. Okay. Good. Understood?
So, but shouldn't alpha be less than pi?
What is it?
Alpha value should be less than pi, right? 180 degrees.
It may not be, because you cannot take your diagram as it is.
No, not the diagram also. If the mass is more, no, nothing.
What is it?
Nothing, sir.
You're forgetting the density and this one, moles. Understood this numerical? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
See, you'll get this idea easily. Equilibrium means your pressure is equal to pressure equal, right? But if you don't get this idea for this question, this step will not come, right? Because PV is equal to nRT, so V is directly proportional to number of moles. Here also, when this, how many of you have done this question? Helium and oxygen. Okay.
I did not do it.
Okay. What's the next question?
Assuming a sample of an ideal gas in a vessel, the velocity of molecule are.
This is fourth question. Okay. The velocity is between 2
2 and
meters
5.
per second and 5 meters per second. Correct? Velocity and velocity of molecules V and number of moles are related and molecules are related as N is equal to 7V minus V square minus 10. The most probable velocity in sample is, so tell me this, in VRMS, V average, V MPS, which has highest velocity? Correct? That you have come right now. See, what I want is most probable velocity, right? Most probable velocity means the common velocity of all the gas molecules, which have, I mean, commonly, right? Most of them will have the same velocity, right?
Yes, sir.
So that means with respect to, can I do it like this? Tell me. The velocity of the most samples, if I equate it to 0, I'll get my MPS, VMPS. Yes. Number of moles which have the same velocity, no?
Yes,
Correct.
Yes, sir.
Over.
3.5.
So V is 3.5. So 7 minus 2V is equal to 0.
So V is 7 by 2, 3.5.
Clear? Understood?
Yes, sir.
Yes, sir.
What's the next question?
So the second question, two conducting movable pistons.
I have to go to the top. Wait. Yeah, okay. Two conducting movable smooth pistons are kept inside a non-conducting adiabatic container with initial positions as shown. Gas is present in three parts, A, B, and C, having initial pressures as shown. Now the pistons are released. Then final equilibrium position length of part A will be. This is B, the pressure is 2P. This is A, the pressure is P, and this is C, the pressure is P. It is L by 3, L by 3, hence it will be L by 3, right?
Yes, sir.
Initially, all the lengths are same, right? But the pressures are different, correct?
Yes, sir. So the second one will expand. The B part will spread.
No. I'm trying to get the easiest way. So B will expand, of course. A reduces, C reduces. Hmm. He needs equilibrium part of length of part A, right?
Yes, sir.
Okay, good. See, let me say A moves, the new equilibrium position is X. Okay?
But can we take PV is equals to constant?
No, that's what I'm trying to do. See, let me say the new equilibrium position is X. Okay? So, number of moles in A before and after should be same, right?
Yes, sir.
Can I use that concept? Because these are movable pistons and there is, so this is like a closed system, right? Heat, neither mass are entering or leaving the system, isn't it?
Yes, sir.
So number of moles in A initial should be equal to number of moles in A final, right? So number of moles is P into volume. So area into L by 3 can I take?
Yes, sir.
Divided by RT is equal to P into area into X.
Well,
But pressure changes, right? Divided by pressure changes, temperature will change, isn't it?
so pressure is not changing. Initially, they are holding the blocks, like later they're releasing the blocks.
Mohit, when see here when a piston moves this side, it's trying to compress, no ma? Understood? See, this side piston and this side piston will move, and after some time, the new equilibrium positions, let me say it is here, and this is here, right?
Yes, sir.
How can you say the pressures will not change? Okay. Now, new equilibrium positions means, can I say the pressures are same?
Yes, sir.
Yes, sir.
Clear? Similarly, for B also the same thing happens, right?
Yes.
Number of moles in B initial should be equal to number of moles in B final. It is 2 times pressure, right? Initial into
Yes, sir.
area into initial is
L
L
by
by
3
3
by RT is equals to P dash A.
equal to, the pressure is constant, P dash into
L by 3
area.
L by 3 plus 2x by RT.
Instead of that, can we take an easiest one? Total is L. This is X. This is X. So this length will be L minus 2X. Correct? See, if this moves by X, this also C also moves by X now. Same pressure, no?
Yes, sir.
Yes,
So
sir.
X, 2X. So this will be L minus 2X, right? Divided by, it's an adiabatic process. So temperature also will be same, right?
Yes, sir.
It's an adiabatic container, non-conducting adiabatic container.
Yes, sir.
Clear? So let this be equation 1. Let this be equation 2. You need X, huh?
Yes, sir.
Yes.
Okay, I'll take 1 divided by 2. PA by RT gets cancelled. 1 by 2 will become X by L minus 2X. X is L by 4. Clear?
Yes.
Okay. Any doubt in this? paper is very lengthy. Next question. What is next question?
In the diagram of select process.
A, B, and C.
Yes, so the
Shivani.
As I said, this I'll tell you this numerical. Once I tell you another numerical. Okay.
Okay, sir.
I had a doubt in my brain.
No, I'll do it because I think there's another numerical which also have the same maximum temperature or something.
Yes, sir.
Yes, sir.
So when I tell you that, I'll tell you this. This you'll easily understand. Okay. What's the next question?
Ideal gas in the container with the piston as one of the walls. There's a little hole in the wall opposite to the piston through which the gas leaks out of the container at the rate R. Number of molecules escaping the container per second is R. So now the gas is heated as well as compressed such that its temperature becomes 4 times its previous value. And the pressure becomes 2 times its previous value. Now the rate of the gas outflow will be.
Okay. Gas molecules are this one, no? They are leaking, right?
Yes, sir.
And the problem is he has given
Heated as well as compressed.
Heated as well as compressed.
gas leaks out. That is the problem. If it doesn't leak out, no, it's not a problem for us. This is question number.
7.
It's not 7. Okay.
So 6 is the tag.
We'll do it 6. Yeah, 7. The gas leaks out of the container at a rate of R. So number of molecules escaping per unit time, right?
Yes, sir.
Is given as R. Now gas is heated. Gas is heated as well as compressed. Temperature 2 is 4 times temperature 1 and 8 times pressure 1, correct?
Yes, sir.
Yes, sir.
Okay. Number of molecules escaping the container per second. I'm trying to get the relation between number of moles escaping and this one. Number of molecules escaping the container per second. Okay. Okay, see, I'm gonna go for the concept of volume here. Okay. See, if volume is reducing, number of moles escaping will increase, isn't it?
Yes, sir.
So can I say the number of moles is indirectly proportional to your volume? No, R, not this, 1 second, R.
Yeah,
R is inversely proportional to V,
yes, sir.
and R is directly proportional to the number of moles leaving, right? So can I say R is directly proportional to N by V, T per second only, no?
Yes.
Correct?
Yes, sir.
So can I say this is number of moles initial minus final divided by volume? Clear? So yet V1, let it be N1, yet V2, let it be N2. Correct?
Yes, sir.
So now use this. P1 V1 divided by N1 T1 is equal to P2 V2 divided by
N2.
N2 T2. Use this relation, get the answer. So this will be P1 divided by N1 by V1. T1 is equal to P2 divided by N2 by V2 into T2, right? This is R1.
R1 and R2.
By R1 T1 is equal to P2 divided by R2 T2. So okay, R2 you require, right?
Yes, sir.
R2 is equal to P2
P2
R1 T1 divided by
P1 T2.
P1 T2. P2 is 8 times of P1 R1
P1 by P.
divided by 4, isn't it?
Yes, sir.
So 2 times.
R.
This 2
I
times.
think they have given the answer as 4R. Just
Hmm.
one.
See,
Yes, sir, they have given it as 4R.
it cannot be 4. Pressure is becoming 8 times and your temperature is becoming 4 times, no?
Yes, sir.
I'll raise an objection for this question, okay? Anything else? Next question.
A piston can freely move inside a horizontal cylinder from both ends.
One second. Big question. Initially, the piston separates side space of cylinder into 2 equal parts, each of volume V0, in which an ideal gas is contained under the same pressure P0 and same temperature. What work has to be performed in order to increase isothermally the volume of one part of the gas 2 times compared to that of the other by slowly moving the piston? Correct? Ay, 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 ay. 2 times volume of one part of the gas, 2 times compared to the other by slowly moving the piston. Okay. It is contained the same. Initially, piston separates the inside of this. This is question number 8.
Yes, sir.
Okay. Let me say this is your cylinder. Closed from both ends. Initially, the piston separates this. So this is your piston. It separates equally, right? So let this be L by 2, and let this be L by 2. Separates, right? Each part has a volume V0 and V0, in which an ideal gas is contained under same pressure P0, P0, and same temperature delta as T0 and T0. What work has to be performed in order to increase isothermally the volume of one part of the gas 2 times compared to that other part? So for example, now I try to move the piston by distance x this side. Okay? Clear?
Yes, sir.
So isothermally, PV is constant, isn't it? Correct?
Yes.
So P1 V1 is equal to P2 V, right? Now see, this piston work has to be done, correct?
Yes, sir.
So let me say initially let area be A. Okay, area be A. The work has to be performed. So first of all, force you have to apply is P2 minus P1 into area, isn't it? Delta P into area is the force which has to be applied, isn't it? Therefore, work done is, for example, let me say I'm moving it by distance of dx. It will be delta P into area into dx, isn't it? Area into dx is your dv. Clear? This is the work which has to be performed by us to move the piston, isn't it? Yes or no? So
Yes,
let
sir.
me say initial volume is V0. So it will be P1 into V1, can I say will be V0 plus area into X is equal to P0 V0. Similarly, your P2 into V0 minus area into X will be equal to P0 V0. Clear?
Yes, sir.
This is for first chamber, Amma.
Yes, sir.
And this is for your second chamber. I'm applying my Boyle's law for both. Right?
Yes.
From this, calculate what is your P2 minus P1. Let area into X. This area into X be V, some volume. P2 and P1 will, what will be this P2 minus P1? P1 V naught plus P1 area into X is equal to P2 V naught minus P2 into area into X. So V naught, if I need this, this will go that side. Do a little calculate, tell me P2 minus P1.
AX into P2 given by V naught everything, sir.
How much is it?
AX into P2 plus P1 V naught.
P2 plus P1.
I need all only V's and this one's here. Why again P2 is coming this side? I only need my P's in this one. Oh my goodness. Understood? See, P1 V naught plus P1 into V area into X is equal to P2 V naught minus P2 into V I'll take, right? So from this V naught taken common, it will be P2 minus P1, P1, P2 minus P1 is equal to this went that side, so this goes that side. V taken common, it will be P2 plus P1, isn't it?
Yes.
So from this P2 plus P1 divided by P2 minus P1 is how much? V naught divided by V, correct?
Yes.
Yes.
Clear? So component and dividend, but I need P2 minus P1, no?
Yes, sir.
Okay, do one thing. From this equation, again get your P2 and P. See, from here, P2 is P naught V naught divided by V naught minus V, right?
Yes, sir. From that we'll get 2 V naught AX by V naught square minus AX square.
How much? 2 P naught V naught
V naught by two P naught V naught AX by V naught square minus AX square.
minus AX square, right?
Yes,
AX
sir.
we have taken it as V. So 2 P naught V naught into V divided by V naught square minus V
Minus
square.
V square.
We know, see, I'm taking, okay, the volume of left hand is 2 times the volume of right hand, isn't it? So volume of left hand is 2 times volume of right. Volume of left is V naught plus V is 2 times V naught minus V, isn't it? Now V naught minus V, no? Clear? So from this, V is equal to, now I can do 1 by 3 times of V naught, isn't it?
Yes.
Clear? Now what is he asking? Work done, no? So your work done is integral TdV, isn't it?
Yes, sir.
Which is P2 minus P1 into your dV, right? So
Yes.
P2 minus P1 is integral 2 P naught V naught V divided by V naught square minus V square dV. Clear?
Yes,
sir.
So your integration limits will be from 0 to V, right? So take it this side, V by V naught square minus V square dV.
And by log V naught square minus V square.
0 to V. Is it minus this only?
Minus of that.
So this will be equal to minus P naught V naught log V naught square minus V square divided by V naught square. Correct?
Yes, sir. So if we substitute V as 1 by 3 V naught,
Substituting it means
8 by 9. 8 by 9.
8 by 9 means minus
Because V naught log 9 by 8.
minus P naught V naught log 8 by 9.
Yes, sir.
So or else it will be P naught V naught log 9 by 8. See, for me only it took how much time? Anyhow, next question. What?
Can you scroll down, sir? Thank you, sir.
Yes, sir.
Next question.
Moles of a monoatomic gas in state A having critical pressure P naught and temperature 3 P naught is taken to a state B pressure 3 P naught and temperature P naught by
Question number is
9.
Why these kind of questions? I don't know. I mean, see how this question is also. This has temperature and pressure. Is it?
Yes, sir.
C B A. I think this is 3 T naught.
Yes, sir.
I think this is T naught. And this is T naught, but the diagram is also wrong. Idiots. P naught. 3 P naught.
27 P
naught. The process equation is P square T is constant, isn't it?
Yes, sir.
State B is taken to state C, keeping volume constant. So B to C volume is constant, correct? Work done is 0. It is coming back to state A, keeping temperature constant. So A to C is your isothermal process. A to B is going according to the equation P square T is constant, isn't it? Heat supplied by the gas during the complete cycle is what we require, right?
Yes, sir.
See, from this, it's a polytropic process. So from here, P square into T is nothing but PV is constant, isn't it? So this will be PV power 1 by 3 constant.
Yes, sir.
This is A to B to C and C to A. Therefore, work done in polytropic process WAB is equal to what is your work done? NR delta T divided by X1. So NR into T naught by 3 minus T naught. What is our? What is it?
minus T2 ఉంది సార్.
Huh?
T1 minus T2 ఉంది సార్.
Which one number?
T0 minus T2 by 3 ఉంది సార్.
NR delta T divided by x minus 1 only, no? So this will be 3 gets cancelled. 1 minus 3 is minus 2. That is 3 T naught, no? Then 3 T naught, 9, 8. So work done in AB is minus 8 R.
T naught by 2.
No, everything gets cancelled. No. 3 is 9. T naught minus 9 is minus 8. 3 gets 4 R T naught. Huh?
Yes, yes, 4 R.
Minus or plus?
Plus because in the denominator also we have minus 2. So in numerator minus 6 also.
Okay. Clear?
Yes, yes.
So therefore your heat in AB will be how much? Delta U in AB plus delta W of AB, right? Delta U is NCV delta T plus 4RT now, isn't it? Hello.
Yes, sir.
What monatomic gas? Put your value of CV and delta T you already know, right?
Yes, sir.
So how much you will get that? Number of moles is 1 only. 2 moles. 2 gets cancelled. 3 gets cancelled. 8. How much you got? 12 1.
Minus 4 R.
Minus 4 RT naught.
Yes, because T naught by 3 minus T naught by
5. See whatever you do, this one. Okay. So now your BC work done is 0, isn't it? Delta U of BC, please get me how much is it? B to C. NCV delta T again. Four RT naught. From this delta Q in your BC is 4 RT naught, isn't it? Now go for your delta CA. It's an isothermal process, right? So it is nRT log P1 divided by P2. So 2 into R into 3T naught log 27 divided 27 only, no?
27 by 1.
By 1. 27 by 1, huh?
Yes, sir.
27 by 1. This is 3 cube, comes out, 3 is 9, 9 2 is 18.
18 or T naught.
RT naught log 3, correct?
Yes, sir.
Therefore, your delta Q net, right, is equal to delta U net plus delta W net, right?
Delta U net will be 0. Cyclic process. So RT into 18 log 3 plus 4.
Plus 8 RT, yeah?
Yes, sir. 8
Yes, sir.
So how much you got?
RT naught into 18 log ln3 plus 8.
8 plus 18 log 3, yeah?
Yes, sir.
The next question. One second. Hello. చెప్పండి. తెలియదమ్మా. ఏం లాస్ట్ డే? ఇవాళ నుంచి షెడ్యూల్ లేదు. వాయిస్ కట్ అవుతుంది. ఏం రాలేదు. 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 Yes, what's the next question?
Curve in the figure shows an adiabatic compression of an ideal gas from 15 meter cube to 12 meter cube, followed by an isothermal compression to a final volume of 3 meter. There are 2 moles of the gas, total heat of gas equal to
Again, question number is
10.
Still we are in 10 only. And see how much time it's taking. This is volume. This is pressure. It is going like this. And from here, it is going down like this. Like this. Okay. $400. Pressure is in pascals. The volume is in meter cube. This is easy question only. 12, 15. This guy is at 3 meter cube. Curve in the figure shows an adiabatic compression of an ideal gas. So this is an adiabatic compression, right? Followed by an isothermal compression. This is isothermal compression. There are 2 moles of gas. The number of moles are given as 2. Total heat supplied is equal to. Adiabatic compression, there is no heat. No, we just only have to find out your isothermal. Isothermal, your delta Q is nRT log V2 divided by V1, isn't it?
Yes, sir.
nRT is nRT, do we know?
No, sir.
We can find out now. T1 V1 is equal to nRT1, no? Or else nRT you put as P1 V1 log V2 divided by V1, okay? So 400 into volume is how much? 12 into log 3 divided by 12. So 4,800 log 1 by 4.
Oh, log 1 0
You'll
minus
get the answer minus. So
all the options are in
minus
minus.
4,800 into 2
2 log 2.
log 2. So do the calculation. Understood?
6652, sir. Minus 6652. It's there, the third option.
Okay. Next question.
Graph shows the hypothetical speed distribution of sample of n gas particle. Section 2. For V is greater than V naught, Dn by dV is equal to 0. Graph is given.
KTG. Speed,
Yes, sir.
and is dn divided by dv. Okay, it is going in a straight line path. So this is V naught, and this is A. Speed distribution of sample.
Yes. dn by dv is 0.
dn by
dv is 0.
no for v greater than v naught. No,
Ah,
for v greater than v naught, dn by dv is 0.
yes, sir.
No, we have to calculate v average no, first. Because in options, VRMS, V average is given, no?
Yes, sir.
Yes, sir.
Okay. No, I think the graph is wrong. dn by dv graph is A, na? That is a maximum point. Okay, fine. V A. Okay, see if I take area under curve, if I take area under curve, the area is half into V naught into A, right? This will be area under curve. Can I say area under the curve will give you my number of molecules?
Yes, sir.
So from this, A V naught is equal to 2n. First option is correct.
Yes, sir.
Clear? Now we need V average. What is your V average formula? We know it is V1 plus
V1
V2
plus
and
V2
V1 plus Vn
divided by N.
by n. Correct?
Yes,
So
sir.
I take n common and I say this will be, we'll take the other formula which is there for this. See, this can also be written as 1 by n integral, okay, v into n, the function of v into dv. Clear? V average. The formula which I didn't teach you because you don't require this formula. Clear? So it will be 1 by n integral 0. Beyond v naught it is not there, no? Correct?
Yes, sir.
Yes, sir.
So it will be n is how much? A by v naught into v into dv. Do it. Integration. No, wait. It is only n dv, not v into n dv. Correct?
So V square by 2.
So get your v this side.
So you'll get A V naught by 2N.
How much is it?
A V naught by 2N.
A by 2.
A by 2n. This is the option. One second. See. Oh, it's been years I have used this formula. 1 second. So if I take all n, this will be n of n to v. All dv's will take dv. This goes that side and v average. So no, yeah. See, first equation which I wrote is correct. Your V average is equal to integral V dN, that is V into, first what I wrote is correct, N dV divided by, okay, understood, divided by N. This is correct. VRMS square is equal to, what is your VRMS square?
V1 square plus
1
V2
by N integral V square N of V dV. Because integral, see, IRMS square is equal to, if you remember, I squared dt divided by integral dt, isn't it? The same one. Then you do this, how much you'll get? 1 by N V square dV, no? V square dV. Do it. Do the integration and get me from here 0 to V0. Similarly, this is from 0 to infinity. So VRMS square is equal to excuse me, 1 by N integral V0 only, no? After V0, everything goes to this one. V square A by V0 into V into dV.
So it will become
V naught square by 3n.
Huh?
A V naught square by 3n.
A V0 square. Clear?
Yes, sir.
Next question.
Number of collisions of molecule of a gas on the wall of a container per meter square. Number of collisions of a molecule of a gas on the wall of a container per meter square will be increase if temperature and volume both are doubled, increase if temperature and volume both are halved, increase if pressure and temperature both are doubled, increase if pressure and temperature both are halved.
That's a theory question, no?
Yes, sir.
Why can't I see that question anywhere? 1 second.
A one-line question, sir. One-line question.
So should I send you the PDF, sir? Sir?
I don't know what PDF I got. The
So
question number is?
12.
12. Section 2.
Can you read the question? I somehow missed the question. Read it again.
Number of collisions of molecules of a gas on the wall of a container per meter square will and then option A, increase if temperature and volume both are doubled. Option B,
Number of collisions of a gas molecule per
on the
meter,
wall of a
right?
container. Yes, sir.
They're asking if we increase the volume and temperature, will they increase, correct?
Doubled, yes, sir.
No, it will not, because when you increase the temperature, the number of collisions of course increases, right? But the volume, that does not have anything with your this one, right?
Collision.
Next, what's your next option?
Increase if temperature and volume both are halved.
Temperature is halved and volume is also half, it will increase. The number of gas molecules which collide will increase if you increase the temperature. If both temperature and volume are half, they will increase. Pressure, you are going to take the concept of pressure.
Pressure in the volume, or if you decrease the temperature, again the molecule will flow and the collision will decrease, right?
We have to talk about the pressure also. If temperature increases,
No, temperature is the volume. Pressure is not counted in this second one.
It's both temperature and volume, both are half.
Yeah. See, that's what I'm saying. Both are half. Okay, what's the third option? The third option.
Decreases the pressure and temperature, both are counted.
Pressure increases, temperature increases, collision increases.
Yes,
That's
sir.
So that's correct.
third option.
So pressure and temperature both are half.
It does.
I want to understand the B one, because if the temperature decreases, then the collision should decrease and the volume
Volume also half.
Mhm.
Will remain the same.
Yeah.
So this is the concept we see, right?
Mhm.
So that can be
Next.
Gas undergoes a cyclic process A.
This you can do. Pressure and density curve you can do. Right.
Yes.
Simple only. Density constant means the same mass volume is constant. PC work done is zero. CD work done is negative.
It's negative.
Hmm. 14th question.
A monoatomic gas, ideal gas undergoes the process ABC.
Now see, this thing, I think I'll tell you this. You have a class at 10 o'clock.
10:30.
10:30, huh?
yes, sir.
Okay, I'll say because it takes at least 10-15 minutes time. Once I tell this, then understand that maximum number is this. One point I left.
The sixth one.
Yeah. You can see how easy it is. One million users. My eyes are straining the limit. B to C, right?
Yes, sir.
Okay, good. Now see, he says a monoatomic gas undergoes a process A, B, C, correct? Now he's asking what is the heat given. First option is heat given to a gas, right?
Yes, sir.
So heat given to a gas in the whole process he's asking. So delta Q of ABC will be delta U of ABC plus delta W of ABC. So you can calculate the work done. It is area under the curve, right?
Yes, sir.
Can you calculate it? Hello? Can you calculate the work done?
Yes.
Now, I need my for U, A, B, C. If I know A and C, I can get my internal energy, isn't it? Because my delta U is F by 2 nR delta T, isn't it? So temperature at A is 2 PV divided by nR, and temperature at C is 6 PV divided by nR, isn't it?
Yes. Yes.
So your delta U is 4 PV into F by 2, isn't it? So 2 FPV. It's a monoatomic gas, isn't it?
Yes, sir. It's monotonic.
So it will be 3 by 2 into
Into
FP.
Yeah.
See why F again.
So can you directly use PV is equals to nRT and do?
1 second. Did I do calculation mistake? 2 PV, 6 PV, 2 is 3, 2 PV, 2 PV.
It's
Correct,
correct.
no, you know? Into N. It is 3 PV, no? Correct?
Sir,
What am I?
I think it's wrong. That's why.
Which one?
3 PV, but
So can we not use PV is equals to nRT directly? Because we know pressure and temperature at pressure and volume at 2 points. So temperature.
That is what I have done now, ma.
we can
So
do like
first of
1 by 2 to
Called as, what is your degrees of freedom for a monoatomic gas? 3, right?
By 2
3 by 2 into what are the number of moles of the gas?
and
It's not given, right? So
yes,
nR into 6. So 4 PV divided by nR, isn't it? 6
Yes,
PV.
so it is 6 PV.
6 PV is your internal energy, right?
Yes,
So
sir.
change in internal energy is 6 PV. Work
And
done, did anybody calculate?
10.5 PV.
Achha, so work done is 10.5 PV. Therefore, your delta Q will be 16.5 PV, right?
So yes, sir. So it's correct.
Heat given option A is correct. D is also correct. Change in internal energy is 6 PV, no?
Yes, sir.
Now, you need molar specific heat, right?
Yes, sir.
Yes, sir.
Delta Q divided by delta T is equal to C. Yes. Hello.
Yes.
Yes.
Basic definition. So 16.5 PV is your delta Q. Delta T, how much is it?
4 PV by nR.
4 PV, no?
Yes, sir.
33 by 2. So it will become 33 by 8. Option C is also correct. Now he's asking maximum temperature. No? See the process how I do. See, it is going from B to C.
Yes.
If you see, this is an isothermal curve. This will be an isothermal curve, and this will be an isothermal curve, right? TB, TC, TA, correct?
Yes, sir.
So now see, if you see your BC, can I say y is equal to minus mx plus c format is there?
Yes. Yes.
Decreasing slope now, ma.
Yes, sir.
Yes, sir.
So at B, my pressure is 3P and my volume is
2E.
2V.
at C, my pressure is P and my volume is, substitute these two in this, get me your M value. 3P is equal to minus M into 2V plus C. And P is equal to minus M into CV plus C. What is your M value? 4, 2 minus P divided by 2V. Yes.
Yes.
Yes, sir.
Now, I know my PV is nRT, isn't it?
Yes, sir.
So from here, can I say this is P is equal to minus M into V plus C, right? See, put your M here, get your C also. Understood? Substitute M in any of the equation, 1 or 2, get your P, 2V gets cancelled. Minus of minus is plus, C is 2P, right? Yes or no?
Yes.
So now, see how I'll do. Instead of P, can I write minus MV plus C into V is equal to nRT?
Yes, sir.
So M is how much? P by 2V, right?
And yes,
So
P by 2
P by 2V
plus C
into
into V
V plus C into V is equal to nRT, right? So once you get it, do dt divided by dV is equal to 0. At that, you will get your temperature max. Clear?
Yes, sir.
Understood?
Yes, sir.
If you're getting confused, so PV, all this I don't know. The alternate way of doing it is X into Y is equal to nRT, isn't it? So X into Y is mx plus C is equal to nRT, right? So mx square plus x into C is equal to nRT. From this, differentiation on both sides, mx square plus xc is equal to nr into dt divided by dx. Clear? So it will be 2mx plus c x is equal to nr into dt divided by dx. And again, what is this? dt by dx is 2mx plus c. So do all these things, you will get it. Answer? Clear?
Yes, sir.
From here, get your dt divided by dx equated to 0. You'll get in terms of x. X is nothing but volume, right?
So like this is the quadratic equation in terms of x, so we can solve it like that. X is equals to minus b plus or minus root b square minus 4ac by 2a. That's
Why
similar.
all that? He's asking maximum value. Maximum of a function is when the first prime of the function becomes 0. Why do you go for quadratic equation and all that nonsense? He's just asking the maximum of a function, no?
Yes, sir.
Now can you do that question which I have left?
Sixth one.
Yes, sir.
The same pattern, no? Clear?
Yes, sir.
You see how
P, I'm getting it as 0.
Huh?
P, I'm getting it as 0, sir.
No, why you'll get 0, Amma? PV by 2 plus CV is equal to nRT. So from the T is equal to PV by 2 plus CV by nR. dt by dv P by 2 nR plus C. C is how much? Something you told, no? C. 2 PV or something. 2 PV, 2P, no?
2p, sir.
2P. Substitute that. You will get your answer. Why you will get 0? You want me to do?
Can you do so?
Minus mv square divided by nr plus cv divided by nr is equal to t, right? So t is equal to minus mv square divided by nr plus cv divided by nr dt divided by dv, right? So minus m divided by nr into 2v plus c divided by nr. You have to equate it to 0, right?
Yes.
So minus 2mv plus c is equal to 0, right? So
Yes, sir.
2m into v is equal to c. So v is equal to c by 2m, correct? So minus, at this function, the t will be maximum. Therefore, minus m by nr into what is v? C square by 4m square plus c by nr into what is v? C by 2m is your temperature max. So temperature max is equal to 1m gets cancelled. C square divided by nr into 4m plus c square divided by nr into 2m minus. Clear?
Yes, sir.
Now substitute your c values, m values which you have got. Clear?
Yes, sir.
Understood? Any doubt in this? You
No,
want me to send this?
Yes, sir. Can you send that once?
okay.
Yesterday date was 26, no?
Yes, sir.
Yes.
Yes, sir.
I have posted it in the Google Classroom as a material. Just check, I'll be online.
Yes, sir. 26 advanced paper discussion.
Yes, sir.
They didn't give the key, no?
They only give the answers, not the questions.
Ayyo, ayyo.
They only give the option A is correct, B is correct. How they got it?
That's what. See, this is what happens if this paper is actually really tough. Okay, I don't know why they gave this difficult paper.
That was
Okay.
first week of revision.
So it just
But maths also is
demotivate
not
people, right?
Even maths we got like same levels. It also was difficult.
No, I mean they should not do like that. Because you will get your confidence hampered, no?
That was the first exam they do this.
They should at least consider that, this is first exam, let us give a little easy.
So what I think is the examiner saw all the graphs and he's like, graphs, it's going to be easy. So he gave every graph that's there in advanced section, like level 3 or level 2.
No, but these are not even from your material. Anyhow, so I've sent it in the Google Classroom. Just go through it. Okay. And if you have any doubts, just ask me. The remaining questions, I'll see if I can send a solution for those.
Yes, sir. Thank you, sir.